कल साइन आपने कैसे किया?
हो गया? क्या ब्लूटूथ और कनेक्ट कर लेता हूँ ना।
तो चल जाता है ऑफिस
कहाँ
से
पे
तो।
है ब्लूटूथ इसमें? मोबाइल डॉट फ्लाइट टूर्स पावर मोबाइल लिंक स्क्रीन ब्लूटूथ। क्यों इसका लैपटॉप कौन सा पहले ओपन करना यार? इसमें बैकग्राउंड अगर चेंज हो जाए तो कर दो ना सर इसका। हो गया सर ये कनेक्ट ब्लूटूथ। हाँ एयरडॉप सुप्रीम।
कट कर दिया ना, अब उल्टा कनेक्ट किया सर, वो लेफ्ट में जाएगा, ये राइट में जाएगा। अजय सर उल्टा कनेक्शन हुआ है आपका, लेफ्ट राइट, राइट टू लेफ्ट। वॉइस भी बस फिर ठीक हो गया, फिर ठीक हो गया। ये तो देख यार कुछ नहीं करना, आपका वो ऑन रहेगा।
नहीं
वीडियो ऑन रहेगा।
थोड़ा सा देखो।
ओके अब ठीक, आप जो बोलोगे
काम तो घर
ये
पे
स्क्रीन
रोज
शेयर
रहेगा।
करें, ठीक है?
मेरे घर पे रोज काम है, मैं यहाँ बैठा हूँ, मेरा घर तो काम ही नहीं हो रहा है।
इसको नहीं दिखाना है,
बस आपको अपने
आपको दिखाना है,
नौकरी को
क्योंकि ये स्क्रीन ऑटोमेटिक शेयर
ठीक है जाओ।
ठीक है सर, ये आपका फेस दिखाना है, ठीक है? बस रिकॉर्ड हो रहा है, रिकॉर्ड हो रहा है।
हाँ
सर
रिकॉर्ड। गुड मॉर्निंग एवरीवन।
आपका ईएल नहीं मिलेगा,
Today we will start the electromagnetic waves.
ईएल तो समिति देगा ना, सीएससी
Today we will start the topic on electromagnetic waves. So in electromagnetic waves, in this topic, first we will study the electromagnetic waves, and after that we will study some topics of ray optics
यादव जी।
also. So my voice is clear. Am I audible?
Yes sir, Yadav ji, you are audible.
Okay sir, thank you sir.
And screen is also very perfectly
So we will
visible.
start the topic today, electromagnetic waves. In electromagnetic waves, this portion electromagnetic waves in your CBSE exam, this may be of 3 marks or 4 marks. So in this topic, first of all, we will study the displacement current. We will study the displacement current. Electromagnetic waves is a different kind of waves. We study in last 11th class in wave chapter that wave particle travel through medium. If we jerk a string, then wave reach to other end to the particles. But in electromagnetic waves, there is a no particle. Wave travel through vacuum, can travel through vacuum also. So this is a totally different kind of wave. That's why we are studying it this chapter in a different chapter other than wave chapter in this class 12. So in this, first of all, we will study the displacement current. First of all, we will study the displacement current. So what is displacement current? It is given by Maxwell, James Clerk Maxwell. Displacement current is given by James Clerk Maxwell. What is displacement current?
बोलो सर, क्लियर है।
Consider first, if there is a, this is a region. This is a region in which magnetic field is present. In which magnetic field is present. And this magnetic field is increases with time. If magnetic field is increases with time, this magnetic field is increases with time, then we know that there is some induced current in the circuit. There is some induced current in the circuit. If magnetic field is inward and it is increases, then by Lenz's law, this magnetic field is increasing inward direction. So our induced current will be anti-clockwise. How? We will, this magnetic field is increasing inward direction. So according to Lenz's law, the flux will change and this will oppose. So induced current will be in anti-clockwise direction. If induced current in anti-clockwise direction, it means current is flowing due to changing magnetic field. Current is flowing if current is flowing, then it means electron, charge particle is moving. Charge particle are in motion. So current is flowing in anti-clockwise direction. It means charge particle electrons are moving opposite to this direction. Charge particles are moving opposite to this part. Current. Charge particle means electron, because electron has a negative charge. And direction of current and direction of electron both are opposite to each other. It means if electrons are moving in this direction, if electrons are moving in this direction, then magnetic field cannot move the charge particle. It means there must be electric field. There must be electric field. If negative charge are moving in opposite direction, then electric field is in opposite direction, because there is force on charge particle. So this is the direction of electric. Similarly here, this is the direction of electric field. It means what happen here, if we change the magnetic field, then there is a induced electric field. If we change the magnetic field, then there is a induced electric field. Similarly, reverse also occur. If changing electric field is there, then there is a magnetic field also produced. Some magnetic field also produced there. Okay. So in this case, what is the relation in displacement current? What is the relation in displacement current? If we take the plate of capacitor, if we take a capacitor and we connect it to a battery, then this negative terminal and this is the positive terminal. So this plate of capacitor will have some positive charge, and this plate of capacitor will have some negative charge. Plus minus charge is there. It means there is a current in the circuit. Here plus charge develop and here minus charge develop. Positive and negative charge develop. It means there is a current in the circuit. According to ampere, this is the current which we call conduction current. So if we take any point here, consider a point P. If we take any point here, consider a point P. Then what is the direction of magnetic field? Current in this direction. So we will put our thumb of right hand in the direction of current. Then this is the magnetic field. So this is the magnetic field. It means if here we apply the Ampere law, Ampere's law, what is Ampere law? Integral on closed curve B dot dl equals to mu naught I. This is the Ampere. If we apply here Ampere law, then there must be some magnetic field. We can solve it. Integral on closed curve B dot dl. What is the direction of magnetic field? This is the direction. In the direction of curl of finger, and dl orientation of the loop, we will also take in this direction. It means angle theta is 0. So we can write P integral dl cos theta. And what is theta? Theta is 0. So cos 0 is 1. And consider the radius of this loop. This Ampere loop is R. It means what is the circumference of the loop? Circumference of the loop is 2 pi r. It means there is some magnetic field. That magnetic field is mu naught I by 2 pi r. This is the magnetic field in the wire. But here around the wire. But if we take any point between the plates of capacitor, this is the plate of capacitor. We connect it to a battery. Now, if we take any point in between the plate of capacitor, then according to Ampere law, integral closed curve V dot dl equal to mu naught I. This I enclosed by the Amperian loop, if we take any Amperian loop between the plate of capacitor, then it is found by the ampere that here current enclosed is 0. Here no current is enclosed. It means current is enclosed. It means magnetic field is 0. Magnetic field is 0. So Maxwell found that there is a discontinuity. Maxwell found that there is a discontinuity in the ampere law. In the connecting wire, there is a conduction current present, there is a current present, but between the plates of capacitor, there is no current. But between the plates of capacitor, there is no current. It means in the ampere law, Maxwell found a discontinuity, that there is no continuity in the ampere law equation here. So here, when Maxwell put a needle, magnetic needle between the plates of capacitor, magnetic needle or magnetic compass, then Maxwell observed that there is a deflection in the magnetic needle. There is a deflection in the magnetic needle or magnetic compass. It means Maxwell found that there is a magnetic field, although there is no current in vacuum between the plates, but there is a magnetic field. That current and that magnetic field, Maxwell told that it is produced by a current, and that current he named as the displacement current. That current he named as the displacement current. How he find the displacement current? How he calculate the displacement current? This is the capacitor plate. So Maxwell states that as we close the key during charging of the capacitor, as capacitor charge, there is a charge developed on the plates of capacitor. Positive charge on one plate and a negative charge on the other plate. So as time passes, initially there is less charge. As time passes, charge between the plates of capacitor goes on increasing. If charge between the plates of goes on increasing, then between the plates of capacitor, electric field is increasing. Between the plates of capacitor, electric field is also increasing with the time. It means Maxwell stated that electric field is changing with the time. Electric field is changing with the time. Electric field is changing with the time. So if electric field is changing with the time, then it is producing the magnetic field, because when Maxwell put here a magnetic needle, then he found that magnetic needle got deflected. Why that deflected? Because electric field is changing with time. So initially we study that changing magnetic field. Initially we study that changing magnetic field is induced electric field. But now Maxwell proved that electric field, if changed with time, then it will also produce the magnetic field. If electric field change with time, then it will also produce the magnetic field. That is the magnetic field between the plates of a capacitor. And he also derived from here the expression of a current. Electric field change with time. Electric field, if electric field change, then it means electric flux will change with time. If electric field change with time, then it means electric flux will change with time. Then what is the displacement current? It is change of electric flux. It is change of electric flux. What is the displacement current? It is the change of electric flux. So d phi by dt, and here one term also that is called epsilon naught. So displacement current, he found that epsilon naught d phi by dt. So Maxwell stated that in these wires, in these connecting wires, there is conduction current. Maxwell stated that in these wires there is conduction current, and between the plates of capacitor there is displacement current. And the conduction current and the displacement current together makes the current, displacement current both together makes the current continuous in the circuit. He also proved that this displacement current and this this conduction current, both are equal. He also proved that this displacement current and this conduction current both are equal. Both are equal. How? Displacement current ID is equal to epsilon naught di by dt. So phi, what is phi? Phi is the electric flux. So we can write this electric flux as charge by epsilon naught. We can write it as charge by epsilon. So according to Gauss theorem, so it means displacement current. So epsilon naught is a constant, so it will come out of the d by dt. So we can write displacement current is dq by dt, and this is also the conduction current. This conduction current. So Maxwell proved that there is a continuity in the current. There is a continuity in the current that Ampere was not able to prove. So Maxwell improved the Ampere's equation. Maxwell improved the Ampere's equation, and a new equation was given that is called Ampere-Maxwell equation. A new equation was given that is called Ampere-Maxwell equation. And what is that equation? Ampere-Maxwell equation. Ampere's equation. Ampere's equation was integral on closed curve B dot dl equals to mu naught I. B dot dl equals to mu naught I. Ampere's equation was B dot dl equals to mu naught I. This is the Ampere's equation. And what is the Ampere-Maxwell equation? Ampere-Maxwell equation. Maxwell improved this equation, and that equation is integral closed curve B dot dl equal to mu naught I plus IT. Mu naught I plus IT. This I is also called IC. IC means conduction current and ID means displacement current. IC means conduction current and ID means displacement current. So this equation is called the Ampere-Maxwell equation. This is the equation. So in a circuit, through the wires, there is conduction current, and in between the plates of capacitor, there is a displacement current. So conduction current and displacement current together makes the current continuous in a circuit. So this is the displacement current. It is a current which produced in the region in which the electric field and hence the electric flux change with time. Electric field and electric flux change with time. So if magnetic field change with time, then it will produce the electric current. If magnetic field change with time, then it will produce electric current. That we study in electromagnetic induction. But if electric field change with time, electric field or electric flux, then it will also produce a current, and that current is called a displacement current. Okay? Changing magnetic field produce induced electric field, and changing electric field will produce displacement current, and if current is there, then magnetic field will also be there. Okay? So what we learn? Changing magnetic field generates electric field. Similarly, changing electric field produce magnetic field also. So both relations are true. Both relations are true. Faraday states that changing magnetic field produce electric field and electric current. Similarly, Maxwell states that changing electric field or changing electric flux also produce magnetic field, displacement current, and if there is current, then there will be magnetic field. So this is the equation of displacement current, epsilon naught d phi E by dt. Here phi E is the electric flux. Here phi E is the electric flux. So this is the next case one. When we take the in case one, when we take the Amperian loop outside the plates of capacitor, this is the Amperian loop, and this is the second case when we take it between the plates of capacitor, passing through the plates of a capacitor. Okay. So this is the displacement current. This is the displacement current. This is the electric field between the plates of capacitor. This is the electric field between the plate of capacitor. You studied that if this is the positive charge, this is the negative charge on the plates of capacitor, then electric field is from plus to minus, and the value of this electric field is sigma by epsilon naught. This electric field is sigma by epsilon naught. We can write also sigma and charge upon area. Sigma and charge upon area. So this is the electric field between the plates, and this is the electric flux. So current is dq by dt. So I equals to d by dt. What is q? From here we can write q equals to pi epsilon naught. So this is the pi epsilon naught. Epsilon naught comes outside. So displacement current is epsilon naught d phi by dt. This is the displacement current. And this is the improved equation. This is the Maxwell Ampere equation. This is the Maxwell Ampere Maxwell equation. This displacement current had by the Maxwell. This displacement current was had by the Maxwell. So if there any problem in the displacement current, then you can ask. If there is any problem in the displacement current, then you can ask. Okay. Now on displacement current, one question, this type of question can also come in the displacement current. This is the capacitor. We connect it to a battery or potential. This is the capacitor. In this question, consider the value of capacitance is given. Consider the value of capacitance is given. It is 100 microfarad or 10 microfarad. Consider the value of capacitance is given. Consider this value is 10 microfarad. This is the value of capacitance. And this potential is changing with the time. Rate of change of potential. Rate of change of potential. There is a rate of change of potential. Rate of change of potential means dV by dt. Rate of change of potential means dV by dt. Consider rate of change of potential is given as 5 volt per second. Consider rate of change of potential is given as 5 volt per second. Then what is the displacement current between the plates of a capacitor? Then what is the displacement current between the plates of capacitor? As you know, the formula of displacement current is epsilon naught d phi by dt. This is the formula of displacement current. Epsilon naught d phi by dt. So what we can write this as displacement current is equal to epsilon naught d by dt phi e. What is phi e? Phi is the electric flux. So what is electric flux? We can write it as E dot A. E is electric field, A is area. Cos theta, theta is 0. If we take this Amperian loop, then both are in this direction. If this is the empyrean loop, then electric field from plus to minus in this direction, right direction, electric field, and normal. Normal means area. Area is also in this direction. Both are in the same direction. It means theta is 0. If theta is 0, then cos 0 is 1. So this is the electric flux. So we can write displacement current as equal to epsilon naught d by dt E. What is E? E is the electric field. So we can write electric field as V by T. Here D is the separation between the plates into area. So we can write it as this. So this is epsilon naught, this is area, and this is separation. Okay. Or we can write one step more, epsilon naught. This plate is constant, so it will come outside. Separation between the plates. This separation is also constant, so it will come outside. And d by dt V. What is V? V is the potential here. V is the electric potential. So epsilon naught A by D. What is epsilon naught A by D? Epsilon naught A by D is the capacitance of parallel plate capacitor. So we can write ID equals to C. C is the capacitance into dV by dt. Into dV by dt. So capacitance is given in the question. It is 10 microfarad, and dV by dt, rate of change of potential, is also given. It is 5 volt per second. So we will put both. So displacement current is equal to C. What is C? 10 microfarad, and dV by dt is 5 volt per second. So 10 into 5, 50, and it will come in microampere. 50 microampere. So this is the displacement current. Okay. So this is the displacement current. Now electromagnetic waves. Electromagnetic waves. For a region where there are no charge and conduction current, Faraday and Ampere law takes the symmetrical form. This is the Faraday and Ampere's law takes the symmetrical form. Electromagnetic wave. Electromagnetic wave is a different kind of wave. Electromagnetic wave is a completely different kind of wave. That's why we are studying it in a different chapter in class 12. We had not studied it with the wave chapter, that in class 11. How is this wave is different? How is this electromagnetic wave is different? Because if I am speaking something, then I press the particle near my mouth, and that particle reaches the ear of the listener. That's in this way wave is travel. If we jerk a string, then the wave reaches to other end of the string through the particles of the string. Okay, so this is the wave. But in electromagnetic wave, almost all type of waves are electromagnetic wave, part of electromagnetic wave. The light from the sun reach to the earth, that light does not require any medium. So electromagnetic wave is a different kind of wave. It does not require any medium for its propagation. So if we jerk a string, then in that string, the particle of the string transfer the wave, particle of the string transfer the wave. So when electromagnetic wave come from the sun, light wave come from the sun, then which particle oscillates, which thing oscillate in that wave? When we jerk a string, then particle of the string oscillate. Okay, oscillations mean wave. And when sunlight come from the sun to the earth, then which thing is oscillate? Then in this there is electric field and magnetic field that is oscillate. Varying electric field and varying magnetic field. Varying means these electric field and magnetic field will change with the time, will change with the time. And how this electric field and magnetic field is produced? Like, if we have three cases. In first case, if charge particle is at rest, charge is 2 and it is at rest. Rest means its speed is 0. If charge particle is at rest means its speed is 0. It means this charge particle will only produce the electric field. This charge particle will only produce the electric field. In second case, if we have charge particle and it is in motion, motion means its speed is not 0. Its speed is not 0, but its speed is constant. Its speed is constant. Its speed is not changing. Its speed is constant. Consider there is a wire. In the wire, charge particle is moving. If charge is moving, it means current will produce. It means current will produce. If there is current, then around the current carrying wire there is some magnetic field. So if charge particle moves with constant speed, it means it will produce both field. It will produce electric field as well as it will produce magnetic field. Okay, these are two cases. But how electromagnetic waves are produced? How electromagnetic waves are produced? If charge particle is there and it is moving with non-uniform speed. If charge particle is moving with non-uniform speed. Non-uniform means its speed is not constant. It is moving with non-uniform speed. Its speed is not constant. Its speed is changing with time. If charge particle speed is changing with time, it means there will be some acceleration in the charge particle. Its acceleration is not equal to 0. If charge particle move with some speed, non-uniform speed change with time, then there must be some acceleration in the charge particle. It means charge particle will accelerate. It means charge particle will accelerate. Charge particle will accelerate. So a accelerated charge particle produce both type of field, that is called electric field and magnetic field. That is called electric field and magnetic field. So a accelerated charge particle will produce both type of field, that is called electric field and magnetic field. And these electric field and magnetic field, what is the difference between this electric field magnetic field and this electric field and magnetic field? If charge particle accelerate, then these electric and magnetic field are time varying. It means they will change with the time. These electric field and magnetic wave, what is oscillating in that wave? Electric and there. Electromagnetic wave is a wave. Electromagnetic wave is a wave in which electric and magnetic fields are perpendicular to each other and also perpendicular to the direction of propagation of a wave. Means these electric field and magnetic field will oscillate in a perpendicular direction. Means if electric field is in the x direction, magnetic field is in the y direction. Both are perpendicular, and also wave will travel in perpendicular direction. Then wave will travel in z direction. If electric field is in x direction, magnetic field in y direction, then wave will propagate in z direction. It means electric field, magnetic field, and propagation of wave all are mutually perpendicular to each other. All are mutually perpendicular to each other, in an electromagnetic wave. In an electromagnetic wave. This is the diagram of electromagnetic wave. Electric field here, electric field is in y direction, magnetic field is in z direction, and wave is propagating in x direction. So in an electromagnetic wave, both field and propagation of wave are mutually perpendicular to each other. It means we can say that electromagnetic wave is a transverse wave. Electromagnetic wave is a transverse wave in nature. Variation in both electric and magnetic field occurs simultaneously. Both will vary. Both will change with time. Therefore, they attain their maxima, minima at the same place and the same time. Maxima means this. This is called the amplitude of wave. This is called the amplitude of wave. This is the maxima. This is the maxima in plus direction, and this is the maxima in minus direction. This is also called minima. So for both wave, electric field wave and magnetic field, both have the maxima, minima at the same time, same place. Both will reach their zero value simultaneously. Both will reach their zero value simultaneously. So this is the property of electromagnetic wave. This is the property of electromagnetic wave. Next property, the direction of electric field, magnetic field are mutually perpendicular to each other. The direction of electric field, magnetic field are mutually perpendicular to each other as well as to the direction of propagation of a wave. Electric field, magnetic field, both are perpendicular to each other, and the direction of propagation of wave also perpendicular to the electric and magnetic field. The electric field vector E and magnetic field vector E are related by this equation. Related by this equation. E equals to B into C. E equal to B into C. E is the electric field of a light, because electromagnetic wave comes from the sun and there is no atmosphere. Electromagnetic wave means a light wave. So it travels in vacuum with this speed, c, speed of light, and with the topic magnetism in velocity filter, or we can magnetic field and speed. The velocity of electromagnetic wave, the velocity of electromagnetic wave in free space. This is the velocity. C equals to 1 by root mu naught epsilon. This is the relation. C is the speed of light. The value of speed of light is 3 to 10 raised to power 8 meter per second. When we put the value of epsilon naught here, epsilon naught means 8.85 into 10 raised to power minus 12. And when we solve this, then the value of speed of light will become this. And also this is the speed of light in vacuum. This is the speed of light in vacuum. If we have to find the speed of light in medium, then we will use this relation. 1 by root mu epsilon. Then we will use this relation V equals to 1 by root mu epsilon. And we studied in magnetism chapter that we can write mu as mu naught mu r. We can write mu as mu naught mu r, and we can write epsilon as epsilon naught epsilon r. We can write epsilon as epsilon naught epsilon r. So V speed, it is equal to 1 by root mu naught epsilon naught. 1 by root mu naught epsilon naught. 1 by root mu naught epsilon naught is c. What is c? Speed of light. So we can write here c, speed of light, and what remains? Root mu r epsilon r. Root mu r epsilon r. This root mu r epsilon r is refractive index. This root mu r epsilon r is a refractive index. So speed of light in medium we can find by V equals to C by N. N is the refractive index of that medium. N is the refractive index of that medium. Similarly, we can also write N equals to C by V. Refractive index is equal to C, speed of light in vacuum, upon V in medium. So this is the velocity. Next property, EM waves obeys the principle of superposition. Superposition principle means that you studied in Coulomb's law, superposition principle, in magnetism also. Similarly, the EM wave obeys the principle of superposition. Means we can add the electric field and magnetic field in the form of vector addition. Next, electromagnetic wave carry energy as they propagate through space. This is divided equally between electric and magnetic field. Electromagnetic waves carry energy. Okay. Not only electromagnetic wave, all waves carry energy. All waves carry energy. If a wave travel, then particle carry the energy. One particle transfer the energy to the next particle in a string wave. Okay. Similarly, when electromagnetic wave travel, then it carry energy from sun to earth. Heat energy is coming, light energy is coming. Okay. And this is the energy. In electromagnetic wave, what is there? In electromagnetic wave, there is electric field and magnetic field. This energy is equally divided in both field, in electric field as well as magnetic field. This energy is equally divided. In electric field, this energy is half epsilon naught E square. And in magnetic field, this energy is E square upon 2 mu naught. And these both energies are equal. And these both energies are equal. This energy is divided equally between electric and magnetic field. We can prove that these energies are equal. How we can prove that? QE equals to half epsilon naught E square. Energy in electric field is 1 by 2 epsilon naught E square, and we studied now E equals to V into C. V is the magnetic field and C is the speed of light. So we can put here that energy in electric field will be equal to 1 by 2 epsilon naught E square. What is E? E is V. So E square is V square C square. E square is V square C square. So energy in electric field, it is equal to 1 by 2 epsilon naught V square H is and C square. C is the speed of light. We studied recently that C speed of light is equal to 1 by root mu naught epsilon. This is the speed of light, 1 by root mu naught epsilon naught. So C square is equal to 1 by mu naught epsilon. What is C square? C square is equal to 1 by mu naught epsilon. So we can put this value here, C square. So what is C square? 1 naught, both will cancel. This epsilon naught and this both will cancel. So energy equal to what remains in the numerator? V square, and in the denominator 2V naught. And this is energy in magnetic field. So from electric field energy, we reach magnetic field energy. Hence, both energy are equal. The energy in electric field Yes, if any doubt is there, you can ask. Okay, no problem. Listen. So from an electric field energy, we get a magnetic field energy. It means both energy are equal. So the total energy is divided equally in both electric field and the magnetic field. Next, electromagnetic waves can transfer sunlight, then you will get heat energy. And momentum also. What is the momentum of electromagnetic wave? Momentum is equal to energy upon speed of light. Energy upon speed of light. So if energy get transfer, then momentum will also get a transfer. More significance is given to electric field. Therefore, electric field is called light vector. EM wave do not require material medium to propagate. EM wave do not require material medium. That's why electromagnetic waves are called non-mechanical waves. Mechanical means which require a medium, and non-mechanical waves means which does not require any medium to propagate. So electromagnetic waves do not require any material medium. So these are called non-mechanical waves. An oscillating charge which has a non-zero acceleration can produce electromagnetic wave. Electromagnetic. We unified the electric and magnetic field. We unified both the fields, electric field and magnetic field. So oscillating charge. How electromagnetic waves produce? Oscillating charge produce the electromagnetic wave. So an oscillating charge which has non-zero acceleration. Non-zero acceleration means speed is not constant. If speed is not constant, then there will be some acceleration. That is non-zero acceleration. So if non-zero acceleration, they can produce both time-varying electric field and magnetic field. So if time-varying electric field and magnetic field is there, then it means there is electromagnetic wave. This is the electromagnetic wave. So next is EM spectrum, electromagnetic spectrum. Electromagnetic spectrum. Next is electromagnetic spectrum. So electromagnetic spectrum. Electromagnetic spectrum. Almost all kind of waves are electromagnetic wave. So they consist a spectrum that is called electromagnetic spectrum. In electromagnetic spectrum, it will consist of first this electromagnetic spectrum consists of radio waves. First is radio waves. In electromagnetic spectrum, first is radio wave is there. Then after the radio waves, there is microwaves. Radio waves, then microwaves. And after the microwaves, there is infrared wave. Infrared, or we can call it IR. Infrared, or we can write it IR wave. So in electromagnetic spectrum, first is radio waves, then there is microwaves. After the microwaves, there is infrared wave. After that, there is visible region. Visible region, VIBGYOR, like this. VIBGYOR. Written in reverse order. Radio, micro, infrared, then visible region. Visible region means VIBGYOR. VIBGYOR write in reverse order. Then UV rays, then X-rays, and after X there is gamma ray. X-rays and gamma ray. This is called electromagnetic spectrum. This VIBGYOR is the visible region. This VIBGYOR is the visible region. Out of the electromagnetic spectrum, from the complete electromagnetic spectrum, we can only see in this Vibgyor, this visible region, Vibgyor. We cannot see by our eye these radio microwaves, but we can see only this visible region. That is Vibgyor. Why we write this in a reverse order? Because if we travel from radio, if we go from radio to gamma rays, then in this way the frequency of wave increases. The frequency increases. If we go from radio to gamma, then frequency increase and wavelength decrease. Frequency increase and wavelength decrease. Okay, so you know least frequency. Radio wave has the least frequency and gamma ray has the most frequency. Radio wave has the least frequency and gamma ray has the most frequency. Similarly, the wavelength of radio wave is highest. Wavelength of radio wave is highest and the wavelength of gamma ray is lowest. Wavelength of gamma ray is lowest. So when we travel, this is the electromagnetic spectrum. It consists of radio, micro, IR, Vibgyor, visible region, UV, X-ray, gamma ray. So if we travel from radio to gamma, then frequency of waves increase and wavelength decrease. So you have to remember this spectrum, and also you have to, in this chapter, you have to remember the production of EM waves, the use of EM waves, properties of EM waves. Okay. Frequency value, wavelength value, what is the range of frequency, what is the range of wavelength. From this, the 3 marks will come. Next, this is the table that you have to remember. This is the table. There is most probability that wavelength range they produce, what is the use. So you have to remember this. Similarly, microwave, this is the range of wavelength, this is the frequency range, this is how they produce, and this is the use. So you have to remember all these things. So these are this is the electromagnetic spectrum. Wavelength range, frequency range, production, detection, ये सब production, use, ये सब आपको याद है. You have to remember all this complete table, because there is most marks will come from this table, from this electromagnetic spectrum, and you have to remember the formula of displacement current also. The formula of displacement current. So this is the electromagnetic wave, complete electromagnetic wave. If you have any problem, doubt in this topic, then you can ask. If you have any problem in this topic, then you can ask. Okay, no problem. Now we will start our next topic, ray optics. Now we will start the next topic, that is ray optics. Next topic is ray optics. In optics, we study about light. This is the study of light. So in ray optics, first we will study the reflection, then refraction, and after that we will study optical instruments. Optical instrument. So weightage of this portion is more in your CBSE exam. So this is the important chapter, important topic, because EM waves, from EM waves there is 3 or 4 mark, but optics is of high weightage. So you have to study carefully this chapter. So in this ray optics, first topic is reflection of light. First topic is reflection of light. It is very simple topic. You also study this topic in your class 10. Reflection of light. Reflection means the phenomenon of bouncing back of light in the same medium after striking a surface, and that surface here is a mirror. That surface here is mirror. It's called reflection of a light. If light fall on a mirror, then it will reflect. Consider this is the mirror. This is the mirror, and if a ray of light incident on the mirror, then just after the light incident, we will draw a normal on the mirror. Normal means that is perpendicular to the surface of a mirror. Normal means that is perpendicular to the surface of a mirror. So this is the incident ray. The angle between incident ray and the normal. This angle is called angle of incidence. The angle between incident ray and normal, that is called angle of incidence. Yes, if any doubt you can ask. Okay, let us continue. So this is the incident ray and this is the normal. The angle between incident ray and the normal is angle of incidence, and this is the reflected. The angle between normal and reflected ray is called angle of a reflection. This is the law of reflection. This is the reflection. So what is the reflection? Bouncing back of light in the same medium. Light comes from this medium, and after reflection, after striking on the mirror, light goes back into the same medium. Light goes back into the same medium. This is called reflection without changing the medium. This is the difference between reflection and refraction. In refraction, what happened? The medium of the light change. But in reflection, only the path of light change. There is no change in the medium. There is no change in its medium. So there is law of reflection. First law of reflection state that this angle I and this angle R both are equal. The angle of incidence and angle of reflection both are equal. This is the first law of reflection. This is the first law of reflection. Second is the incident ray, reflected ray, and normal all lie in the same plane. The incident ray, reflected ray, and normal all lie in the same plane. Same plane means these three vectors. We can fix in these three, incident ray, normal, and reflection. We can fix them on a wall. हम इनको एक wall पे लगा. These are not in space. These are in plane. We can fix it on a wall, on a page of paper. Okay. So these all will lie in the same plane. Incident ray, reflected ray, and the normal to the mirror all will lie in the same plane. This is the law of reflection. First law is angle I and angle R are equal. Second is incident ray, normal, and reflected ray all lie in the same plane. If angle I and angle R are equal, then we can write both as same. So we will write both as theta because I and R both are equal. Next is sign convention. This is the plane mirror. This is what? This is the plane mirror. This mirror is the plane mirror. But now we will study the spherical mirrors. Now we will study the spherical mirrors. Spherical mirrors means concave mirror or convex mirror. They are made of a hollow sphere. They are made of a hollow sphere. This you also studied in class 10. Okay. So sign convention. Sign convention means which sign we will take positive, which sign we will take a negative. Positive, negative. So sign convention is all distance are measured from the pole. You all know the terminology. This is a mirror, concave axis is called a principal axis. This axis is called a principal axis, and this point is called a pole of the mirror. This point is called a pole of the mirror. So, what is the first sign convention? In this sign convention, all distance are measured from the pole of the mirror. All distance are measured from the pole of the or from the optical center of the lens. This is in the case of lens. So all distance, either concave mirror or convex mirror, all distances we will measure from the pole the incident light are taken as positive. The mirror from this object. Light will incident on the mirror from this object. So this is the incident light. This is the incident light. So if we all distance we will measure from the pole, consider this is the object. Consider this is the object. So when we measure the object distance, then we will start from pole. We will start from a pole. So from pole to object. Incident light direction is this. This is the direction of incident light, and we will start from pole. This direction. So both are opposite. If both are opposite, it means this distance, this object distance is negative. So if we move in the direction of incident light, that we will take positive, and opposite we will take a negative. Third sign convention is the height measured upward with respect to x-axis and normal to the principal axis. Normal means perpendicular upward. X-axis of the mirror or lens are taken as positive. The height measured downward are taken as negative. What it means is, consider this is the principal axis. This is the mirror. Consider this is the mirror and this is the principal axis. This is the object. This is the object. So when we measure the height of the object, then object is above the principal axis, So we will take this height as a positive. And similarly, consider this is the mirror, principal axis. This is the object or image. Okay. So when we measure this height, then we will come below the principal axis. So this is negative. This is the sign convention. If we measure all, first we will measure all distance from the pole of the mirror. Second, if we measure in the direction of incident ray, that is positive, that distance is positive. If we measure opposite to the incident ray, then that is negative, that distance is negative. Similarly, if we measure the height above the principal axis, that we will take positive, and below the principal axis, that we will take a negative. So these are the sign conventions. Similarly, focal length or focus of spherical mirror. Focal length or focus of spherical mirror. Focal length or focus. So this is the concave spherical mirror. This is the concave spherical mirror. Principal axis. If ray incident on the spherical mirror parallel to the principal axis. If ray incident on the spherical mirror parallel to the principal axis, then after reflection it will cut a point on the principal axis, that is called a focus. So this is the focus of a concave mirror, and we know this point is pole. This point is a pole. So the distance from pole to focus, this distance is called focal length. The distance from pole to focus, this is called a focal length. Similarly, for convex mirror, this is the convex mirror. Similarly, for convex mirror, this is the convex mirror. Principal axis. If ray incident on the mirror parallel to the principal axis, then after reflection they will reflect like this. Okay. And when we trace the reflected ray backward, then it will cut the principal axis. That point is called focus. This point is focus. So here ray actually meet at principal axis. So in concave mirror, this is the real focus, and in convex mirror, ray appear to meet at principal axis. So in convex mirror, this is virtual focus. Okay. So this is the focal length, the distance from pole to focus in both type of mirror, either it is concave or convex. This distance is called a focal length. Concave mirror is also called convergent mirror because it is converging the light. And convex mirror is divergent mirror. It is diverging the light. So if any problem, you can ask. When a parallel beam of light is incident on a concave mirror, the reflected ray converges at a point F on the principal axis, that is called focus. Okay, so same thing is written. The reflected ray appear to diverge in convex, and in concave they appear to converge. So next is relation between focal length and radius of curvature of a concave mirror. Concave mirror or convex mirror. Relation between focal length and radius of curvature of concave or convex mirror, for both it is same. That relation is F equal to R by focal length is half of the radius of curvature. How we can derive this relation? Consider this is the concave mirror. This is the concave mirror, and this axis is called principal axis. This axis is called principal axis. So on concave mirror, a ray of light is incident on a concave mirror parallel to the principal axis. Then after reflection, it will pass through focus. So here, this is the point of incidence. Here, light incident. So if light incident, then we draw a normal here. What is the normal in case of spherical mirror? At any point of the mirror where we want to draw the normal, simply join that point of the mirror to the center of curvature. If we want to draw normal at any point of the spherical mirror, then join that point to the center of curvature. So this is the normal. So this is the incident ray and this is the normal. So angle between incident ray and the normal is called angle of incident. Consider this is denoted by theta. And this is the reflected ray and this is the normal. So angle between normal and reflected ray is also theta. Because we study the law of reflection, that angle I and angle R both are equal. So this is also theta. So if this angle is theta, this angle at point M, this angle is at point M. If this is theta, then this angle at C will also be theta. Because these are alternate angles. So this will also be theta. Similarly, if the angle between this parallel if the angle, total angle, what is the total angle between incident and reflected ray? Theta plus theta 2 theta. So this angle at focus will also be 2 theta because alternate angle. This is the alternate angle. So this will also be 2 theta. Okay. So angle, this is written angle MCP equal to theta. MCP is the pole. This is theta. And similarly, I can write tan theta. So what is tan theta? Tan theta is equal to, we can write MD MD is perpendicular upon CD is this base in triangle MDC. And similarly from triangle MFD, we can write tan 2 theta equals to this perpendicular MD upon this base FD. MD upon FD, this we can write. So this is MD upon FD. And you know, if angle is small, if angle theta is very small, then we can write sin theta approximately theta and also tan theta approximately theta if angle is small. So this angle theta is very small. Why? Because here 99% that we study in optics that are para-axial rays. Para-axial rays means they are closer to principal axis. These are para-axial rays. So if para-axial ray, then these angles theta are very small. So if these angles are small, then we can write tan theta approximately theta and tan 2 theta approximately 2 theta. Okay. So what is theta? Tan theta MD by CD, MD by CD, and tan 2 theta is MD by FD. MD by FD. Okay. So from here, what is theta? Theta comes MD by 2 FD. MD by 2 FD. Theta is MD by 2 FD. So in both equations, consider this is the first equation and this is the second equation. This is the first and second equation. So left hand side is equal. So we will put right hand side also equal. What is the right hand side of first equation? It is MD by CD, and right hand side of second equation, it is MD by 2FD. It is MD by 2FD. Okay. MD by CD and MD by 2FD. So MD and MD both will cancel. दोनों cancel कर देंगे. It means CD is equal to 2FD. CD is equal to 2FD. So from C means center of curvature. D means we can consider D as P. What is P? P is the pole. Why we can assume? If aperture is small, if rays are point D as point P. Point D and P both are same. So this CD we can write as CP or PC, or distance we measure from pole 2FD. This we can write 2FP. So what is CP? Center to pole. This is called radius of curvature. 2FP. FP means focus to pole. This is called focal length. So radius of curvature is equal to twice of the focal length. Or we can say that focal length is half of the radius of curvature. So this is the relation between focal length and radius of curvature of spherical mirror. Either it is concave or convex. Okay. So if any problem in this relation, then you can ask. If any problem is there, you can ask. Okay. So next is this is the path of light rays. This is mirror formula. This is the mirror formula. Okay, this is the mirror formula for concave mirror when real image is formed. You know, you also studied in class 10 that a concave mirror forms both type of image. It forms real as well as a virtual image. So this is the case when real image is formed. This is the case when real image is formed. So real image, when real image is formed, if object is placed beyond the focus, if object is placed beyond the focus, then real image will form. When object is placed on the principal axis beyond the focus, the real and inverted image is formed. So this is the mirror formula. This is the mirror. This is the object AB. AB is the object. So a parallel ray parallel to the principal axis will incident on the mirror at point M. At point M, it incident ray, it will pass through focus. Second, if ray incident on the pole, then it will reflect. This angle and this angle both are equal. Angle I equals to angle R. Similarly, if ray pass from the object, if ray incident on the mirror from the object passing through center of curvature, then it will incident on the mirror, and this ray is called normal. This is called normal ray. So if it is normal, then after reflection it will retrace its path. Okay. So the distance from pole to focus, this is focal length. The distance from pole to B, this is object distance U, and the distance from pole to image, this is image distance. Where all reflecting ray cut, their image will form. Image is A dash, B dash. So we take similar triangles. One is A dash, B dash, F. You can see in the diagram. One is A dash, B dash, F. One triangle is A dash, B dash, F, and second is MPF. MPF. You can see in this diagram. Okay. MPF. If we join from M to P by a straight line, if aperture is small. If aperture is small, like the last topic, we can consider both point D and pole as similar, same point. Okay. So this is the triangle. So from this triangle we can write, from this triangle we can write A, B, A dash, B dash, F. We can write A dash, B dash upon MP. MP this side. Okay. Equals to B dash, F and B dash, F, and this will be F and P. Similar triangle na? So we can write height ratio equals to the base ratio. These are equal. This is the equation. Okay. So A dash, B dash upon AP. Why we write AP? Because MP and AP both have the same height. MP and AP both has the same height. So we can write this MP equals to AP. So we put here AP in first equation. Similarly, we take also triangle A dash, B dash, P and ABP similar. A dash, B dash, P. P means pole and AP, P. A dash, B dash image, AP is object. Similarly, we can write by similar triangle this equation. A dash, B dash upon AP equal to B dash, P upon P. So this is the first equation. This is the second equation. Now, left hand side of both equation. Left hand side of both first and second equation are equal. So we can write their right hand side also equal. So we put their right hand side equal. B dash F upon PF equal to B dash P upon P. Now we know all distance we measure from pole. We measure all distance from pole. So in all term there is pole P, but in B dash F there is no pole. So we can write B dash F as PB dash minus PF. See from the diagram. We can write B dash F as PB dash minus PF. So we write here using sign convention. We can write PB dash as minus it as minus F upon P. We can write as minus F equals to B dash P. B dash P we can write as minus B upon B. We can write this as minus relation 1 by V plus 1 by U equals to 1 by F. Then we will get this relation 1 by V plus 1 by U equals to 1 by F. We will cross multiply this. After cross multiply, we will divide them by UVF. Then we will get the relation 1 by V plus 1 by U equals to 1 by F. This relation is called a mirror formula. This relation is called a mirror formula. This mirror formula is same for both mirrors. Either it is concave spherical mirror or it is convex spherical mirror. It is same for both mirrors. Next is magnification. You can derive the convex formula, mirror formula for convex mirror also similarly by the same method. Next is magnification. What is magnification? Magnification is the ratio of height of image to the height of object. Magnification is the ratio of height of image or size of image to the size of object. Size of image to the size of object. N equals to magnification equals to height of image upon height of object. This is the magnification. Okay. This will come equals to N equals to minus V by, in case of mirror, magnification is negative. M equals to minus V by U. So this is the magnification. Now next is the reflection. This was the reflection. In reflection, there is only change in path of light. There is no change in its medium. There is no change in its medium. But in refraction, both occur. There is change in the path of light as well as change in the medium also. So refraction is the phenomenon of a change in the path of light as it travels from one medium to another. As it travels from one medium to another. When the ray of light is incident obliquely, okay, it should not incident normal. Okay, so this is the incident ray. This is the incident ray. This is a, we take this as glass slab. We take this is the glass slab. This is the glass slab A, B, C, D. ABCD is a glass slab. It is a glass slab. So this is the incident ray. Ray incident on the surface AC of the glass slab. If ray incident, then we will draw a normal there. So this is the normal. So ray incident at this point. So this will refract. If ray go from rarer to denser medium, then it will bend towards the normal. And if it goes from denser to rarer medium, then it will bend away from the normal. Okay. It will bend away from the normal. If any problem is there in reflection, you can ask. In reflection, if any problem is, you can ask. Okay. So let's continue. So this is a glass slab. This is a ABCD is a glass slab. So glass has high refractive index. Glass has a high refractive index in comparison to air. This is the air. Air is present. So glass has high refractive index. Glass is more denser than air. So air is rarer medium and glass is denser medium. So if light ray goes from rarer to denser medium, then it will bend towards the normal. And if it goes from denser to rarer, then it will bend away from the normal. So this is the incident ray, this is the normal. The angle between incident ray and the normal is angle of incidence. And this is the normal, this is the refracted ray. So the angle between refracted ray and the normal is angle of refraction. So again, the light will fall on the surface BD. in the rarer medium, then it will bend away from the normal. So in refraction, there will be change in path as well as change in the medium. So there are three laws of refraction. First, these all will lie in the same plane. Incident ray normal to the surface and refracted ray all will lie in the same plane. This is the first law of refraction. Second, if light pass from one medium to another, then its frequency will not change. Why frequency will not change? Because frequency is the property of source. So it will not change if light will go from one medium to another medium. So what will change? The speed of light change, the wavelength of light change. If light goes from one to other, then speed and wavelength will change, but frequency will not change. And this is the important law, Snell's law. This is the Snell's law of refraction. Snell's law states that consider the refractive index of first medium is mu1 and refract mu for n. Here it is written mu, so we take mu. Okay, mu1 of rarer medium and mu2 of denser medium. Then on this point, consider this point is E. So we can apply Snell's law at E. Consider this point is E. So what is Snell's law? It states that the refractive index of the medium, E is present at the interface. So above E there is a rarer medium and below E there is a denser medium. So first we will write the product of refractive index above E. Above E means rarer medium. So Q1 is the refractive index of rarer medium, multiply by sine angle. What is the angle in rarer? It is I, sine I. Mu1 into sine I. It will be equal to what is the medium below E? Below E is the denser medium. So refractive index of denser medium is mu2. Multiply by sine. What is the angle at E in the denser medium? It is R. So we can write mu1 sine I equal to mu2 into sine R. This is called Snell's law of refraction. Or we can write mu refractive index to sine angle of incidence is constant for a point in mid. Mu into sine I is constant. So this is called Snell's law of refraction. When you study the TIR, reversibility of light, lateral displacement, lens formula, lens maker formula, in these formula you will use these relations, this Snell's law. So Snell's law is very important. Why they write here mu only? Because they take the refractive index of rarer medium as unity. Refractive index of rarer medium as unity. Next is principle of reversibility of light. Principle of reversibility of light states that if a ray of light after any number of reflection or any number of refraction falls on a mirror at right angle means perpendicularly, then after reflection the ray of light will retrace its path. Then after reflection the ray of light will retrace its path. It will retrace its path. Like here, this is the slab, glass slab. This is the glass slab ABC. Okay. So this is the surface AB. This is the surface AB. This is the incident ray. If incident ray fall on the surface AB, this is the normal. This angle between incident ray and the normal is angle of incidence. So after refraction, ray pass through this path. So we put here a plane mirror, and this angle is what? This is right angle, 90 degrees. Then this ray will retrace its and this is the angle. Okay.
after any number of reflection or refraction falls on a mirror at 90 degree, then it will retrace its path. It will retrace its path. Next is lateral shift. Lateral shift or lateral displacement. This is important. Okay, lateral shift or lateral displacement. This is important. It can be asked in your exam. Okay, so this is the glass slab. This is the glass slab ABCD. This is the glass slab. This is the incident ray, normal angle of incidence here I1. Then ray refract into the denser medium. So if it go in the denser medium, then it will bend it towards the, this angle of refraction is angle R1. This angle is angle R1. Again, it fall on the surface CD, on the surface CD. So it will go from denser to rarer. So it will bend away from the normal. Now, what is lateral displacement? If there is no glass slab, if there is no glass slab, then this incident ray will go undeviated, will go straight. It is shown in the dotted line in the diagram. Okay, it will go along this dotted line, along this path. But there is a slab present. If slab is present, then it will go, it go along this path, this solid path. Okay, so this is the point of emergence at the CD. So from here we draw a normal, a perpendicular on the dotted line at point M. So this distance, consider this point E. This distance EM, this distance is called a lateral shift, lateral displacement. So we have to find this distance. Okay. So first we will take this triangle. Consider this point is F and this point is G. Okay. So first we will take the triangle FGE. Triangle FGE. First we will take the triangle FGE. In this triangle, we will calculate the side FE. We will calculate the value of the side FE. Okay. So from here, we can write this angle is R1 and this is 90 degree. So FG is base. What is FG? It is base. So we can write cos R1 equals to base upon hypotenuse. What is base? Base is FG. Upon hypotenuse is, it is FE. Okay. So cos R1 is equal to FG. FG is base. Base is T. What is T? T is the thickness of glass slab. T is the thickness of a glass slab. Upon FE, it is hypotenuse. Right from here, FE hypotenuse is equal to T by cos R1. T E, and we have to calculate EM. We have to calculate EM. So again, we will take the triangle FEM. We will take the triangle FEM. Here, this angle at F, this is delta. Delta means angle of deviation. What is delta? It is angle of deviation. Delta is angle of deviation. By this angle, the ray deviate from its path. So here we can write sine delta. What is sine delta? Perpendicular upon hypotenuse. Perpendicular so then you will get this relation 1 upon cos R1. This is the value of lateral shift or lateral. If you have any problem up to this topic, then you can ask. And next topic we will start tomorrow. So if any problem is there, you can ask. Okay, no problem. Okay. Okay, then I am leaving the class now. You
अब कैंसिल हो गया अब फिर से गया तो मतलब मम्मी के डॉक्यूमेंट्स ठीक नहीं थे तो इसलिए ठीक नहीं हो रहा था।